So moving forward, let's take up the next one, question number 17 from this paper. F be a twice differentiable function on 1, 6. If f2 is 8 and f dash 2 is 5. F dash x is greater than or equal to 1 and the second derivative for all x, it is greater than or equal to 4 in the interval 1 to 6. Then question is roaming around 5, f5, f dash 5, f double dash 5. So let's plan this question. Since f dash x is greater than or equal to 1 for all x in the interval 1 to 6, that means slope of the line joining 2 points, it will always be greater than or equal to 1 if we try to find a line, right? So let's consider one point as 2 and other point as 5 as required one. So we can see f5 minus f2 upon 3 is greater than or equal to 1. That means f5 is greater than or equal to 3 plus f2, meaning 11. Clearly, option number 3 is not correct. Next, also f double dash x is greater than or equal to 4 for all x in the interval 1 to 6. Again, going with the same approach for the function f dash x, whose derivative is greater than or equal to 4. So we have f dash 5 minus f dash 2 upon 3 is greater than or equal to 4. Now the value for f dash 2 is given to me as 5. Alright. So here we get the conclusion f dash 5 is greater than or equal to 12 plus 5, that is 17. Now time to again look at the options. f5 plus f dash 5, the sum of the two, what we are getting? 17 plus 11, that is greater than or equal to 28. Yes, we have reached the correct answer and it is greater than or equal to 28. So let's mark and mention as the required result. So I'm sure this question is clear. Let's take up the next one. Question from complex number. Let u equals 2z plus I upon z minus ki, where z is x plus iota y and k is positive. If the curve represented by real part of u plus imaginary part of u equals 1 intersects the y-axis at 2 points P and Q. A curve is there which is intersecting y-axis at 2 points. Where PQ is 5, length of that intercept is given, segment is given. The value of k is, let's try, substituting z as x plus iota y, we have 2x plus iota into 2y plus 1 divided by x plus iota into y minus k. This is clear. Now here we multiply by the conjugate of this denominator, which is x minus I, y minus k, and same term in denominator. Now, when you try to simplify it, you will get in the standard form what the question is saying, real part of u plus imaginary part of u is equal to 1. So let's write down real part of u plus imaginary part of u is equal to 1. Here we can see real part, it is coming as 2x square. Next, real part will come when these two are multiplied. So minus I square making it plus 1, then 2y plus 1 into y minus k. This is clear. Next, imaginary part, denominator will also be there, we will write later. Imaginary part will be this term multiplied with 2x. So this is 2x multiplied with, say, k minus y. I have taken this minus sign inside. And then next is x multiplied with 2y plus 1, right? Denominator is taken to the second side because it is equal to 1, and denominator is simply x square plus y minus k whole square. Points are clear till this point? Alright. It is given that it intersects y-axis at 2 points P and Q, meaning we need to put x equals 0 in this curve. Instead of simplifying, just put x equals 0 here itself, so that we can see it is changing to 2y square minus 2ky plus y minus k. Here it is 0, this is also 0, is equal to y square plus k square minus 2ky. So this is what we are getting. This is implying that y square, 2ky will be cancelled, plus y, then we have minus k into k plus 1 is equal to 0. It has two values, y1 and y2, so that we can say mod y1 minus y2 is 5. Alright. Since mod y1 minus y2 is 5, squaring both sides, we have y1 minus y2 whole square is 25. That means 1 plus 4k into k plus 1 is 25, or 4k square plus 4k minus 24 equals 0. Divide by 4, we get k square plus k minus 6 equals 0. Minus 6 is equal to 0, right? So equation is k square plus k minus 6 equals 0, which can further give me k as 2 or k as minus 3. Since k is greater than 0, so obviously it cannot take the value minus 3. That means correct answer is k is equal to 2. So now check from the given options. K is equal to 2 is given to me as option number 3. So let's mark and mention as the required result. So I'm sure this question is also clear. Let's consider question number 19 now. If product of two terms is a square minus b square, where a, b both are positive in this order, then dx upon dy at pi by 4 comma pi by 4. Let's try out. Simply differentiating both sides with respect to y, we get a plus root 2b cos x multiplied with 0 and derivative of this one with respect to y, root 2b sin y, plus next a minus root 2b cos y same multiplied with minus root 2b sin x into dx by dy is equal to 0. This is clear. Now we need to put pi by 4 comma pi by 4. When you put here pi by 4 comma pi by 4, you will be getting a plus b, because you can see that root 2 into 1 by root 2 cancelled, multiplied with root 2 1 by root 2 cancelled, so just b, plus here we have a minus b into minus b into dx by dy is equal to 0. So from here we can simply get dx upon dy, let's take it on the other side, is equal to b upon b cancelled. So we are left with a plus b upon a minus b. So I'm sure this part is clear. Directly we can obtain dx upon dy as required in this question. So let's check out a plus b upon a minus b. That is correct answer is option number 3. So I'm sure this question is also clear. Let's take up the next one.